Okay, class, today we're going to go over section 4.2. I'm going to break it into two parts. There's an addition rule, and then after that, in the same section, there's another rule called the multiplication rule. So I'm going to do first the addition rule. So for the addition rule, there's going to be a concept in biology that you will be going over, and that is genetics. When they go through genetics, anything dealing with genes and so forth, they require students to know about Punnett squares. So these next few topics are going to be kind of related to Punnett squares. Okay, so let me go through the book. And so I know it says there addition rule, multiplication rule. We're only going to do the addition rule now, and then I'll do on the next video, I'll make the multiplication rule. So for the addition rule, first definition is called the compound event. So a compound event is any event combining two or more simple events. So we're going to be talking still about probability. And as you recall, the formula for probability was parts over total. So we're gonna use that concept when we cover the addition rule and the multiplication rule. So the addition rule, there's a word, because we are going to cover word problems. There's a term that's going to prompt you to use the addition rule, and that word is the word or. So anytime you see the term or, that means that you are going to use the addition rule. If it doesn't say or, if it says another term and, you're going to be using rules. But if it doesn't say or, and, you're going to use the regular probability formula, which is parts of the total. Right? So here it is. For the addition rule, the term or is going to be used. And so this is how you're going to see it. It's going to be probability of A or event B. That is equal to the probability that in a single trial, event A occurs or event B occurs, or they both occur. Now, there's two formulas. This is one of them, right? This is one of them, but there's another one that I'm going to show y'all. So first one, the regular one, so there's two formulas. Okay, so well, you write the green one, I'll write it also. So the first probability formula goes the probability of A or B is equal to, it has it here, probability of A plus the probability of B. I'm looking at this formula right here. Probability of B minus the probability of A and B. Right, so this formula that you see here will be used, I can't get it, hold on, there you go. That will be used for events that do something. So let me show a picture of it. So to visualize it, we use what we call Venn diagrams. If you've never heard of the term Venn diagram, I'm going to show you what a Venn diagram looks like. Okay, so let me show you what a Venn diagram looks like. So for this particular event, right, when we use this formula, it's supposed to be a plus. We have a Venn diagram that looks like this. So I'm going to denote A to be a certain color and then B another color, right? Right. So this is your universe, the plane. Think of it like a plate, right? Or a table. You're sitting at a table at your home, right? And you have plates that will represent A to be the red plate. And we'll let the green one be the B plate. Now notice what is happening with these two circles. Yes, these two circles are overlapping. So overlap, they intersect, intersect. Right. So two events that intersect or overlap requires us to use this formula. Okay. Now, when do events overlap? All right. So let's suppose, for example, that I have in our class, we have students that have different majors, right? So let's let A equal to all those students in the class that are nursing majors, right? So you are the red. And then we have the other students in the class that are maybe they are business majors, right? So you have business, and then you have the nursing students in my class. This is my class. So what does this intersection mean? That means that they are sharing something in common. Well, those students are sharing, that's the intersection there. They both share that they are taking my stat class. That intersection, that's the overlap. That is the intersection that's occurring. So we use this formula. So I'm going to show you how the formula works. All right, so I'm going to draw another Venn diagram. And just to show you how this formula works. All right, so here's my A again. This is my A, and I have my B, my two plates, which are intersecting, right? They're overlapping. Now let's put some elements. Let's put some items inside the circles. So I'm gonna put some letters. Or numbers. We'll put letters. Lowercase a. So we'll put A, B, C. This one has the D and an E. D and E. I put D and E in there. So there's D and E. D and E. And then we'll put F, G. So, how many elements are in my table combining this set with this set? How many total elements are there? Trying to zoom it in. Well, all you have to do is just count them right. 1, 2, 3, 4, 5, 6. There are 7. There's a total of 7 items or letters, right? In both sets, right? There's 7. All right, so now I'm going to use my formula. There's supposed to be 7. So I'm going to use my formula. Probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay. Now, let's do it in pieces. There's 3 parts to this. Okay, so let's look at this first part. So this first part is saying, all right, look at only the red circle. All right, look at the red circle, the entire red circle. How many lowercase elements are in the red circle? Count them, right? So there's 1, 2, 3, 4, 5. Just the red circle. There are 5. Right, so there's 5. Plus, how many are in the green circle? In the green circle, there's 1, 2, D and C. That's 4. So there's 4 of them. Right? There's 4. And then this part says where are they intersecting? How many elements do they share? Where's the intersection or the share? How many do they share? They share 2. Now, if you think about it, if you go back to our formulas, notice the red one, we counted D and E, but when we did the green, we also counted the D and D. So we're counting D and E twice. One, when we get the count of the red circle, and we're also counting it again in the green circle. So that's the reason why we subtract, is because we are counting these 2 values that they share. We're counting them twice, so we have to compensate. So we have to take it out. We already included it in one of the sets. We got to take the other one out because we're counting it twice. So if I add 4 plus 4, 5 plus 4, that's 9 minus 2, you get 7, which is what our total amount of items that we have. So that's the reasoning behind this formula. So you're counting the elements of A, and you're counting only the elements in the B circle, and then you're taking out where they overlap out, because you're already counting it already in one of those sets. That's where that comes into play. All right, so this is the overlap formula. Okay, that's when two events share something in common. Okay, now I got to show you the second formula. And then I'll let you compare that formula with the one that we just did. All right, so this one goes like this. Probability of A, sorry, oh yeah, probability of A or B equals probability of A plus probability of B. We refer this one to be, I'm not gonna say, I gotta draw another Venn diagram. So let's draw a Venn diagram. And then you tell me, what do we call this process that it's doing? So here's my plate, my universe. I have set A, and I have set B. Right. So notice these 2 sets are not intersecting. They are, the term to it, they are separate. We call it disjoint. Right, so disjoint means that they are separate. There are 2 separate things, right? Let's say, what would be a good example? Let's see, A and B. Maybe people that only have Ford trucks and people that only have Chevy trucks. You're not going to have an intersection, unless you could have, but you're only dealing with these people that just strictly just love Ford. You know what I'm talking about. They just cannot buy any other car. They just stick with Ford. They stick with Chevys. You're not going to have these people getting Chevys or Ford. They're just going to stick to their own kind of car. That's disjoint. Right, so we have disjoint and we have overlap. Those are the 2 formulas that we're going to be using for our addition rule. Now, when you apply your addition rules, we're going to do parts over total plus parts over total minus parts over total. This is going to be parts over total plus parts over total. Now, compare the 2 formulas. Well, if you look at both formulas, one of them has an extra line, right? An extra part to it. Right. This is because they overlap. You're deducting the part where they intersect at. This one didn't have it, so it shouldn't have an extra feature to it. So this one, you deduct the intersection because they overlap, and this one doesn't. This one's disjoint. Okay. All right. Now let's talk about how do you apply this to the Punnett squares. Okay, so let me give you an example of a Punnett square. So the book has on page, I believe this is 148. Here is a square. They call it a Punnett square. Right. So we're gonna be using these Punnett squares. So I'm gonna show you how they work. So this square here, this Punnett square, is they surveyed applicants for a job, and they took a drug test. All right. So notice when you have a Punnett square, you got two units. You got one to describe the columns, right? These two are the columns represent the test results. So when they get tested for drugs, either they come out positive or negative. So these two columns represent the test results. These are columns, categories, negative, positive test result. Okay. Now on the row categories, subject uses drugs, subject not use drugs. They asked the applicants, hey, have you ever used drugs? Either they said yes or they said no. So these are the responses. These two rows represent the responses that the applicants stated, whether they did or they did not use drugs. Here are the results. So you have columns labeled, you got rows labeled. All right. So let's figure out what is the meanings behind these numbers in the box. All right. So let's look at the 480 first. So what does this 480 represent? All right. So this 480 represents those that they tested negative, but they said that they did not use drugs. So they asked them, did you use drugs? Nope. Well, guess what the drug results stated? You're right. They did not use drugs. So these people here told the truth, right? They told the truth. All right. Now let's look at this one right here, this 45. What does this 45 represent? That 45 represents the people who they asked them, did you use drugs? What did they say? They said, yes, I use drugs. Guess what the test results said? You're right. They tested positive. Right? So they told the truth. So these people on the corners told the truth. They said they used drugs. It came out positive. These people said they did not use drugs. Sure enough, they says negative. So the ones that were telling the truth, they called this one is called true positive, and this one's called a true negative because they told the truth. All right, now let's look at this 5. What does this 5 represent? All right, so the 5, hold on 1 second. So this 5, let me get it. This 5 are the people that were asked, did you use drugs? Yes, I used drugs. But guess what? The test results said, no, you didn't. So they weren't telling the truth. I guess they wanted to fit in with the crowd. They lied about them taking drugs. They didn't use drugs. So yeah, they did not tell the truth. That's what that 5 is. Trying to get it to highlight, but I can't get it to highlight. There we go. right? Now this is 25. What are these 25? These are the people that were asked, did you use drugs? No, I didn't use drugs. Liar. The test result indicated that they did. So these are not telling the truth. So the ones that are not telling the truth are called false positive, false negative. Okay, now I'm trying to take the highlights off and I can't. Okay. All right. Got it. All right, so let's summarize. I'll put a picture of mine here on the screen just to share with you how it works. You need visuals. Okay, so let's get my visuals. So I have columns. These columns, the 45, 25, the 5, and the 40, these are the test results, right? This column represents the ones that tested positive, whether they said yes or they didn't. They did use drugs or they didn't use drugs. These are the negative results, whether they said yes, they did use drugs or they didn't use drugs. Okay, those are columns. The test results represent columns. These are the column categories. Row-wise, this row represents the people that use drugs. They said that they use drugs. But this one says that the test result indicated that it did. This one indicated that they didn't. This is subject uses drugs. These are the responses. This row here represents the subjects that stated that they did not use drugs, right? 25 were tested positive, 480 tested negative, right? These are rows. Response represents the rows. Test results represent columns. You may want to label them so that way you know. All right, so once you know what these numbers mean, when you get a table like this, the first thing you do is you gotta get the totals. You want to get the totals of the columns, and you want to get the totals of the rows. So let's add them up. So you always want to do that first. So let's add the row of the subject that said that they use drugs, the response. So this is 50. 50. All right, now I gotta add the subjects that said that they did not use drugs. All right, I'm gonna get my calculator. What is that? 25 plus 480 is 505. And now I want to add the columns. So the columns is going to be, I believe this is 70 and this is 485. So I added the rows and the columns. And those give you the subtotals. Those are the subtotals of the columns and the rows. Now I have to get the grand total. Now, how do I get the grand total? You have two choices. Either you add the two row sums or the two column sums. They're supposed to end up to be the same number. So if I add 50 plus 505, I get 555. You may want to double check. The 70 plus 485 equal 555? 70 plus 4, yep. So either you add the subtotals of the rows or the subtotals of the columns, they're supposed to be the same, this way or that way. So the outer ends is supposed to equal to that. Outer end equals that. Right. All right, now we're gonna answer some questions. So based on our picture, I want to find the probability that the subject uses drugs, said that they use drugs, use drugs, or tested positive. Uses drugs or tested positive. Now I have to determine whether I'm going to do the overlap or the disjunct or the disjoint. Which one am I going to use? Am I going to use the overlap or the disjoint? All right, well, let's go back and look at our units. Let's look at our events that we're using, right? So because uses drugs is a response, and the second event is a drug test result, these two are going to overlap. Notice, I'm going to draw with my pencil. So I know that uses drugs is a row, right? So I'm going to draw a line just like that. Subject uses drugs. And then I'm going to draw a line on my plus. Plus is a column category, so I'm going to go down, right? Notice when I drew these two lines, the two lines intersect, which tells me that I'm going to use the overlap intersection formula. So I'm going to do probability of A plus the probability of B minus the probability of A and B. I got to use that formula, right? So I'm going to calculate the parts over total because that's what I have to do for each of these three quantities. Right, so I know my total. My total is 555. All of them are going to have 555s because that's my total. Now I got to do parts. All right, so my A represents use drugs. Use drugs. So this is use drugs. So use drugs is this row. So that's 50. 50. All right. B is going to represent the people that tested positive. That is a column. Notice the lines, look, the lines point to the out edge. That's going to be the first 50. And then this line goes toward the next one, which is 70. This is the positive. And then the last part is where did they intersect? Look at the lines where they intersected. It intersected at 45. Right. So now you're going to put this in your calculator. You don't have to worry about the bottom part because they all have common denominators. So that 555 stays as it is. But you just have to do the top. So you're going to add 50 plus 70 and then deduct 45. Just type it in your calculator. 50 plus 70 minus 45 gives you 75. And divide. I get 0.135. 135, 135, 135. Ooh, repeating. Weird. Right. And you remember where to round it off? If I want to leave it in decimal, I have to round it off to 3 places. That would be 0.135. If I want to put it in percentage, this would be 13.5. Right? Let's do another example. Right? All right. So Here's another one. I'm going to put my picture up again. I'm going to add up again. I'm going to add up my columns and my rows. So this was, I believe this was, what was that? 70, 45, 45. I'm going to add this 50 plus 505. Grand total was 555. You always have to do that. You got to get the subtotals of the rows and columns, and then you got to get the grand total. Okay. All right. So let's do another one. Let's find the probability of that a person tested negative or not use drugs. All right, not use drugs. All right, so let's see. Are these two events going to intersect or are they going to be disjoint? Well, let's look at our graph, our table. This is a test result. This is a column. So I'm going to draw a line down my column. That's negative. You can't go this way. There's no numbers. I got to draw from that symbol down because those are the numbers, right? And then this is not use drugs. Not use is a response. I can't go up. There's no numbers. So I have to go this way to the right. And notice that they did what? They intersected. So I'm going to use my intersection formula. I'm going to do probability of A plus the probability of B minus probability A and B. And I can fill it in with the units instead of A and B. So this is going to be the probability of negative test result plus the probability that they did not use drugs minus the probability of test result and not use drugs. That's where they intersect. And I'm going to write my three formulas, my three parts over totals, right? They're all going to have 555s in the bottom. Okay, now I'm going to get the total. Get the total of the negative test results. Go to negative, follow the line. Outside the box, there's your total. 45. All right, next one. Not use drugs. Not use drugs as a response. Not use. There it is. Follow it. There it is. 505. And then the last part. Where did they intersect it? Where did they intersect at? They intersected at the value of 480. Okay. So we add and subtract and keep the denominator of 555. So I'm going to add 45, 505 minus 480 gave me 510. So I'm gonna divide. I get 0.91189189189 blah 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 blah. Right, I gotta round it off to 3 places. So 0.919, right? Or 91.9%. So some of you are already thinking, wait a minute. So I think I get this. So you're saying that if I get a row or a column and a row, column, row, they intersect. That is correct. Notice the unit. This is a test result. This is a response. The previous one I had a response and a test result. Yes, that is correct. They only intersect when you have one of these, or one of these, or one of these, or one of these. You're going to be using the intersection. Right. So you're saying, well, when do I use the disjoint? Good question. Let's see. Let me draw another graph, and I will show you when you use the disjoint. Okay, so this was plus, this was minus, uses, drugs, not use drugs. You put in the numbers 45, 5, 25, 480. All right, I'm gonna do my subtotals. This is 70. This is 45. This is 50. Add. Add 50. So grand total, add, either you add that or you add that, they're supposed to end up the same. 555, right? And now let me give you an example of one where you use the joint formula. So suppose that we ask you to find the probability of positive or negative. Why are these two events disjoint? Well, this is a column category. They are the test results. And so is the other one. It's a column. So if I drew a line through this column and this column, notice that my lines do not intersect. They are parallel, which tells you you're going to use the disjoint one, the disjoint formula. So it's the probability of A plus the probability of B. So in our case, probability of plus the probability of negative results. So you'll see how weird it becomes if you get disjoint. But it only happens when you have a 2 by 2. All right, so the total of the positives is 70. The total of the negative test results is 45. If I add them together, I get 555 over 555, which is equal to 1. Interesting. So is there another set of events where they are disjoint other than positive or negative, or negative and positive? Other than that, yes, there's one more. There's another set. What about probability of use drugs or not use drugs? This is another event where they are disjoint. Why? Because these two events are both rows. Row and a row. Okay. Hope I can save my graphs without having to draw another one, so you can see that uses drugs. There's a uses drugs and there's a not use drugs. This time they come out to be parallel lines, but it's on the rows, right? So you end up getting probability of A plus the probability of B, probability of use drugs plus probability of not use drugs, 555 plus 555. The total of the used drugs is 50. And the amount that did not use drugs, is 505. 505. You add them up, 555 over 555. You get 1 again. You end up getting 1 because we are dealing with a 2x2 Punnett square. If you have different dimensions like a 2x3 or 3x2, other than anything other than a 2x2, you're gonna get not 1. So that's how that works, right? So I suggest you get your pencil and draw lines to see if they intersect or not. That'll tell you which formula to use. All right, so let's look at the ones in the book. We'll do 2 examples. All right, so here's we're gonna do 9 and 11. Okay, so here we go. Number 9. What page is it on? It is on page 156. Number 9. All right, so this one is the following table describes the drive-through order accuracy at a popular fast food chains, and the restaurants are McDonald's, Burger King, Wendy's, and Taco Bell. So on your table, you have on the top, notice you have the restaurant names, and then on the row labels, they are whether they're accurate or not accurate. So you have the restaurants, right? You got the restaurants. Can't get it. Restaurants. And then you have the whether they are accurate and inaccurate. All right, so what do we do? So we have to get the sum of all the columns and all the rows. All right, so here we go. So you have to do it, I have to do it. All right, so I gotta write it down. So order accurate, accurate. So it's pretty much accurate, not accurate. All right, our restaurants are Mickey D, BK, Wendy's. I have to just spell out Wendy's, and then TB. You probably will get TB if you eat at Taco Bell. All right, and let me write down the number 329. McDonald's that were accurate, 33 were not. 264 Burger King were accurate, 54 not accurate. 249, 31, 145. I'm doing Taco Bell and 13. All right, so let's add them up. Add up the rows, add up the columns. All right, so for the first row, I got 362. Second column, 318. Third column, 249 plus 31, 280. And the Taco Bell column, 145 plus 13 is 158. Ah, right on the edge. 58. Now I got to get the total of my accurate. So I'm going to add 329 plus 264 plus 249 plus 145. 987. I'm going to add the not accurate column row. 33 plus 54 plus 31 plus 13, 131. And now I gotta get the grand total. 131 plus 987 is 1118. There we go. 1118. All right, so I've got my table ready. All right, I added the rows, I added the columns, rows. We are ready to answer the question. All right, here we go. Number 9. All right, now, are we going to use, here are your choices. Are we going to just use probability formula, which is parts over total? Or am I going to use one of the addition rules? The one that intersects or the one that is disjoint? Disjoint, not disjoints. All right, so let's look at number 9. All right, so let's read it. If one order is selected, find the probability of getting fast food that is not the McDonald's. All right, so remember the term that indicated that you were going to use the addition rule. Is there the word or written in this question? I don't see the word or. That means that I cannot use any of the addition rules. I have to use the parts or total. All right, so I want the probability that it is not from McDonald's. All right, so I know the total. I know the total because I got to use parts over total. I know the total is 555. There's my total. It's 555. Should be in red. No, that's 555. 18 and 111. Yeah, I was getting the number from the other one. It's 1118 is my total. Sorry. Yeah, there's my total. 1118. Right, that's my total. Now I want the numbers that are not from McDonald's. Not from McDonald's. Right? So there's the McDonald's, but I don't want the McDonald's. So I have to add these numbers, and that'll give me the part because I want the not from McDonald's. So I'm going to add 318 plus 280 plus the 158, and that'll be the top part of my formula. So 1118, I'm gonna add those numbers because those are the ones that were not from McDonald's. 318 plus 280 plus 158, 756. And I'm going to divide that by 1118. And I'm gonna round it to 3 places. 676 or 67.6%. Is my answer. So I'm using just parts over total because there's no or stated in the problem. So that's number 9. Hopefully I can use this table again. Maybe I can conserve it. Instead of me drawing another picture, and my little whiteout pen just gave out. Okay. Maybe not. I think I broke it. Oh, okay. So that one didn't work. I don't like these. Why? I like the ones that use. It's like in a liquid format. They smell good. All right, I gotta write it. 318. No 318, right? 318. 31. All right, I'm gonna I'm gonna conserve it. I'm gonna not waste paper. I'm gonna use the same brown. All right, now let's look at number 11. Okay, let's look at number 11 and see if it requires us to use my addition rule. Okay, here we go. So, number 11. Number 11 says, if one order is selected, find the probability of getting an order from McDonald's or an order that is accurate. Ding, 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 ding. Look at that. There is a term or. Or is right there. That means I have to use the addition rule. So let's first write down the event. So they want the probability that it's from Mickey D or accurate. Right? There is the word or. I got to figure out if I'm going to have to use the intersect or the disjoint. All right, so I know Mickey D is a restaurant and accurate is the order, right? So that means what? They're going to intersect. Here's the restaurant, McDonald's. Draw a line. McDonald's down, it's a column. Accurate is a row. Draw a line. Booyah. They intersect. So I have to use the intersection one. You guys don't have to write that, but I do it just because. Right, so I got to use my formula. So probability of Mickey D plus probability of accurate. I'm gonna have run out of space. Minus the probability of Mickey D and accurate. Squeeze it. So I'm gonna have to write down 3 fractions and we're gonna fill them in. So I know my total is 1, 1, 1, 8, 11, 18. I want to get the total of the Mickey D. Mickey D, follow the line. There it is. 362. I want now the accurate. Accurate's a row. Follow it. 987. 987. Now I got to subtract where they intersect. They overlap at 329. So there it is. So now I'm going to go ahead and add the top and subtract. I'm going to keep the 1118 in the bottom. So I'm going to add 362, 987 minus 329. $10, $20. All right, so now I'm going to divide. Now I'm going to divide 10, 20 over 1118. 1118. I want to round it to 3 places. 0.912 or 91.2%. Now you can see the overall picture. I'll give you some time to write it, and then we got to do another problem. And this one's going to be a little bit challenging. Okay. All right. So let's do another one. This time you're gonna have to draw the Punnett square on your own. So let's take a look at number number 21. We're gonna do number 21 together. All right, so 21. So you're gonna have to build one from scratch. Okay, so let's see, 21. All right, so use the results from the one panel THC test for marijuana use, which is provided by the company Drug Test Success. All right, so they're gonna give us the numbers to fill in our Punnett square. All right, so I'm gonna draw. I think they're doing kind of like the drug test. We have positives. We have the positive, negative. Yeah. Okay, so we have just like the drug test. Okay, so my columns are going to be labeled plus and minus. Test results. Are the columns and the rows. And the rows are going to be the results, also the responses. All right, so responses. I'm going to just put yes, they did use, no, they didn't. Did they try marijuana, yes or no? Okay, here we go. All right, so let me show you what I have on my graph. This is what I have labeled so far. We're gonna fill it in. Okay, so I have the test results, plus minus, columns. I got the responses. Did they ever try using marijuana? Yes, no. All right, here we go. Now let's fill in the numbers. Let's figure out to see where all these numbers go. All right, so let's tackle on the first one. It says among 143 subjects with positive test results. Right, we're going to take that part first. Where do I put the 143? The 143 represents subjects with positive test results. That 143 positive, all of the positive test results. 143. That's going to go right there. All the positive, whether or not the people said yes, I did or didn't, that's the grand total of all the people that stated that they tested positive. All right, so that's where that goes. All right, next part. There were 24 false positive results. False positive. False positive. You remember where false positive goes. All right, we got to go back. Go back to our picture that we did with the drug test from the applicants. And let's see where the false positives fell. The false positive was on column 1, the second spot. So that's where it goes, right there, false positive. Okay, so that's where this number, did I pass it? Oops. 24 goes. 24. Come on. 24. Come on, let me get it. Nope. 24. Maybe I do this one. Bam. 24. 24 is going to go here. This is the false positive. There you go. False positive goes there. All right. So because this is the total and these are the no's, what goes there? How do I figure out that number? Well, all you have to do is Subtract 24 from 143. This will give us our count that goes there. 143 minus 24. Let me put that in my calculator. 143 minus 24 is 119. Yeah. All right, let's go back to the problem. Let's do the second part. It says among the 157 negative test results, 157. So where does that 157 go? 157 goes, it's the total of column negatives. 157 goes here. The total, 157. And then there were 3 false negative results. 3 false negative. Let's see. Where was false negative at? Let's go back. False negative. See if we can find it. False negative. Oh, that's the top. That's the top box on the negative. Okay, so it's gonna go. Did I pass it? I think I passed it. That's gonna go. Was it 3? What was it? I don't remember. What was it? 3. 3 pop. 3 is gonna go here. I don't think I wrote this right. Did I? Yeah, that was false negative. Right? False negative. Is that what the column said? Double check. Yep, false negative. Right, now we're gonna figure out what this box is, right? So to figure it out, this is my total, that's 3. So if I do 157 minus 3, I get 154. Bam, 154. So I have the total of my columns already. I just need to figure out the total of my rows. So this would be what, 1, 2, 2, and this would be 178, which gives me a grand total of what? If I add those two and those two, it should give me 300. Should be 300. Okay. Now we got to answer the questions. All right. So let's see if we can answer the questions. So the questions say, how many subjects are included in the study? All right. They want to know what was the grand total. The grand total, I believe, was, I had it in red, was 300. B says, how many of the subjects had a true negative result? True negative, true negative. Where was the true negative? True negative. I believe the true negative was this box. The 154 is your true negative, and this is your true positive. That's B. And then C is, what is the probability that randomly selected subject had a true negative result? All right, so knowing part A and part B, put them together to form your parts over total. Parts over total, 154 divided by 300 gives you 0.513 or 51.3